How does SAR work on Earth observation satellites? Imagine a satellite floating high above the Earth, sending out tiny radar signals that bounce back from the surface below. That's the core idea behind synthetic aperture radar, or SAR, on Earth observation satellites. Unlike cameras that need sunlight or clear skies, SAR can see through clouds, rain, and darkness. This makes it perfect for monitoring our planet all day, every day. SAR works by actively emitting microwave radar pulses toward the Earth's surface. These signals travel through the atmosphere without much interference. When they hit different surfaces, they bounce back to the satellite's antenna. The strength of these echoes depends on what they hit. Rough surfaces like rocky terrain or buildings reflected strongly, while smooth surfaces like water reflected weakly. As the satellite moves along its orbit, it transmits thousands of pulses every second. The radar antenna collects the returning signals, which contain information about the surface features. The satellite's motion helps it create a much larger virtual antenna, called a synthetic aperture. This process allows SAR to produce images with very high detail, even better than what a stationary antenna of the same size could achieve. The signals are processed using special algorithms that measure how long it took for the echoes to return. This timing tells us how far away each object is. Doppler shifts in the signals, caused by the satellite's movement, help refine the details along the flight path. The result is a two-dimensional image where brightness shows how strongly the radar bounced back. Bright areas could be buildings or rocky ground, while darker areas might be water or flat terrain. Because SAR can operate day and night and in all weather conditions, it is used for many important tasks. It helps detect changes in land surfaces after earthquakes or landslides. It can monitor flooding even when clouds cover the area. SAR also tracks ships at sea during the night or in bad weather, providing vital information for security and navigation. Recent advances include larger synthetic apertures and more powerful radar signals. These improvements allow satellites to cover wider areas and gather more detailed data faster. Multiple SAR satellites now work together in constellations, giving us near real-time updates on Earth's surface changes. In simple terms, SAR on Earth observation satellites works by sending out radar pulses, capturing their echoes, and using the satellite's movement to create detailed images. These images cut through clouds and darkness, giving us a clear view of our planet's surface at any time. This technology complements optical sensors and helps us understand Earth's dynamic processes more reliably and continuously.